This disclaimer will explain why I have been very careful about using trademark brand names only for educational purposes and avoided using photographs that I didn't take. Blade purchases are essentially the operating cost of the machine. As I have talked about previously, these combination saws rely on a double twist in the blade path that is very hard on the blades. Optimizing your saw and your cutting procedures is important to keep your operating costs low. Monometallic blades shed teeth. Once they lose a tooth, the adjacent teeth shed rapidly because the blade lowers into the opening of the missing tooth and then crashes into the next standing tooth. Bimetallic blades rarely if ever shed a tooth. The blade runs until fatigue cracks develop from the twisting blade design and upward pressure against the teeth. The cracks almost always start between the teeth. Here is an example of a blade that ran on a saw adjusted per this video series. It ran a very long time cutting steel. The teeth are still razor sharp and none are missing. There are hundreds of cracks visible to the naked eye, one of them finally severed completely. The amount of work done by this blade made the cost of it trivial. Many users choose to purchase the less expensive non-monometallic blades because they have so much trouble with the saw throwing blades. Following the instructions in this series will eliminate blade throwing as a purchase criteria. I want to emphasize that these are my personal preferences and may differ from yours. You may use your saw totally differently from the way I use mine. There is a balance between feed pressures, blade pitch, and speed. Only you can decide what works best for you. Finally, your budget and purchasing criteria may be totally different from mine. Again, we're talking about personal opinion here. I rarely change from 200 feet per minute. Since only square solids will have the same blade contact area, most cutting will require a compromise. Do you feed fast and hard through the upright on a piece of angle, putting a pointed load on the blade, or reduce the feed and then be less than optimal for the flat portion? A round changes area throughout the cut. Only you can decide which compromise you prefer. Should you prevent point sources against the blade or prevent rub on the flats? Both are bad, and I believe only a CNC saw can optimize during the cut. Because my efforts to film this process were complete failures, I've written up this explanation. See if it works for you. First of all, thank you for your efforts to see yourself through this series. I have made claims during this series about resolving frustrating performance and eliminating blade throwing. This is the frame where I add a caveat about these claims. No amount of tweaking can make a used blade brand new again. A damaged blade may not stay on your saw even after you methodically followed my directions in this series. You will run into some challenges in clamping and cutting certain objects. Here are a few tips. Here's a rather overkill demonstration of some part stabilization techniques. Here is an example of using an enhanced stop to cut some small parts where the accuracy is important. The rod is a very hard chrome shaft from an old shock absorber, turned down slightly on the end to fit into the original hole in the saw and retained by the grub screw. The rod is 1/2 inch OD. The tubing is 3/4 inch OD 1/2 ID chrome moly tubing drilled out to 17/32. This partial tray of parts came directly off the saw. Here are the dimensions of the stop blade that work for me. This minor modification to the throat of the saw prevents short parts jamming between the blade and the throat side. Done with the cutoff wheel on a 4.5 inch grinder. That completes the essential guide to the horizontal vertical combination bandsaw. Please leave me any thoughts and comments you might have. If you feel inclined to, please check out my products to increase the safety and utility of this wonderful invention.